Hi everyone, we are going to start a very tough question, bridges in a graph. Here there is a problem which is known as critical connections in a network, where we have to find the number of bridges in a graph. What is the definition of a bridge? Any edges on removal, the graph is broken down into two or more connected components. Means there is a full graph, means a full connected component, and we have to find the number of bridges by, if we remove that bridges, then graph will be disconnected into two or more component. Okay, so that edge is known as bridge. Let's see a problem. Just like we have given node 1, node 2, node 0. This is LeetCode example. Node 3. So there is a edge between 1 and 2, 1 and 0, 2 and 0, and 1 and 3. So here we are seeing, if we disconnect node 1 to node 2, means if we remove edge 2, then there is no problem. The graph is still connected. We can reach any node by any node. Okay, we can reach 3, 1, 0, 2, means all nodes are connected. If we remove this, then also there is no problem. If we remove this, then also there is no problem. But if we remove this node, then you cannot never reach from 1 to 3. So this is a bridge node. Okay, so our task is to find all the bridge node in an unconnected component graph. So we can solve this problem by two ways. First way is a brute force approach. If there are minimum number of nodes, means if there are nodes are less. Okay, so you can check by using DFS for each edge, and traveling DSS we can calculate if we reach every node or not. So this is actually a brute force approach. The optimized approach is our Tarjan's algorithm. What Tarjan's algorithm says, we need to make two arrays. First is time in and second is lower time. Means when at what time we enter a node and what is the lowest time to reach that node. So if we start from 0 and let's timer to be 1. So inning time is 1 and also the lowest time is 1. So from 1 we can reach to 2 at time 2 and the lower time is also 2. So from 0 we can reach 2 as well as we can reach 1. So from 0 to 1 the time become 3 and 3. So from 1 we can reach 0, 2 and 3. But when we go to 2 is already visited. So it means, can we remove 1 and 2 edge? 1 and 2 edge will not be removed, because from 1 2 is already visited, means there is a path to reach 2. So 1 and 2 will never be a bridge. So the lowest time is 3, but we can reach 2 at time 2. So we take its lowest time to its, because we can reach 2 to 3 by another path. So its lower time will be taking as 2. Okay, we can also reach, is 1 and 0 is a bridge? No, this is also not a bridge, because 0 is already visited. This means there is a path to reach 0, and also its lower time is 2, but its 0 lower time is 1. So we can reach 1 before 2. So this is not bridge, and we can take its lowest time to its. So its lowest time become 1. Okay, now we can reach 3. Yes, we can reach 3 because 3 is not visited. But this is a bridge. This is a bridge. 4, yes, because here its lowest time is 4 and its lowest time is its t in time is 3, means its lowest time is greater than its enter time, means you cannot reach before this time. So this is a bridge. So this is a critical bridge. So we can store this answer to our bridge array. Okay, let's see a more greater problem. Okay, so here is a one more problem for more understanding. So let's start timer with 1. So we can reach 1 at time, means t in time is 1 and also the load time is 1. From 1 we can go to 2, so our time is 2 and lower time is also 2. From 2 we go to 3, so 3 and 3. From 3 we go to 4, so 4 and 4. Okay. From 4 we go to 5, so 5 5. From 5 we go to 6 6 6. From 6 we go to 7 7 7. From 7 we go to 8 8 8. From 8 we go to 9 9 9. From 9, here is a problem. From 9 we can go to 6, we can go to 8, but we do not go to parent. Okay, otherwise there is an infinite loop. So if we go to 6, 6 is already visited, so we check, is this is a bridge? No, because 6 is already visited, means there is a path to reach 6. So we take the lowest time of both, means this 6 is reached at time 6 and 9 is reached at time 9, means 6 is reaching before 9. So this is definitely not a bridge, so we take its lowest, so 9 comma 6. So from 8 we go to 10, so time become 10. From 10 we go to 11. From 11 we go to 12. From 12 we again go to 10, but 10 is already visited, so this is also not a bridge, because 10 can be reached before 12. So its lower will take by this, so 12 and 10, means 12 can be reached by 10. Okay, at 10, at time 10. So this is not a bridge. Is at type of backtracking we check 12 and 11, are these two a bridge? Let's see. 11 t in time is 11 and 12 lower time is 10, means 12 is reaching before, reaching at time 10, and 11 time is 11, means 12 is reaching before 11 to 12, means 11 to 12 time is 11 and 12 will be reaching by 10 before 11. So this is also not a bridge. Okay, so let's check 11 and 10. 10 is reaching by 10 and 11 is reaching reach at 11. Its lower time is 10 and it's reaching 11, means 10 can be reaching, so it is also not a bridge. No, it's sorry, it's mistake. Its lower is taken by 11 upon 10. So 10 and 11 it is a bridge. 11 is reaching at time 10 and 10 is also reached at 10. So this is also not a bridge. We can reach 11 at time 10 if we remove this. So let's check 8 and 10. Here 8 and 10 is a bridge. Why? Because from 8 to 10, 8 in time is 10 and 10's lower time is 10, means 8 10's comes after 8. So from 8, before 8 we cannot reach 10. So this is a bridge. This is a bridge. Okay, here in that we can reach 11 before and or equal to 10. Here the lower time is 10, that's why this is not a bridge. But here 10 comes after 8, so that is a bridge. Okay, here 8 or 9 is a bridge. It's here 9, here in time is 9 and here its lower time is 8. It means 8 can reach before 9, so this is also not a bridge. Here 7 and 8, here so we take its lower time to here, so its time become 8 or 8 and 6, means 8 can be reached at time 6. Okay, so 7 and 8, here we check its t in time is 7, its lower time is 6, so this is also not a bridge. Okay, so it's become 7 and 6. Here we check 7 and 6, it reached at its t in time is 6 and its lower time is 6, means they can reach at time 6. If we remove this, then there is no problem. This is also not a bridge, so we can take is lower than this same. Okay, 5 and 6, 5 t in time is 5 and 6 lower time is 6, means 6 comes after 5. We cannot reach before 5, so this is a bridge. Okay, so this is second bridge, this is first bridge. Okay, now we go so and take, if we take lower of this, then 5 is lower, so 5 5. Okay, let's check 4 and 5. Is this a bridge? We can reach here the t in time is 4 and here the lower time is 5, so 5 comes after 4, so this is also a bridge. Okay, I think you are understanding. This is also a bridge because its lower time is 5. It comes after 4. So we can not reach 4 to 5 before time 4. Okay, because lower time is 4, 5. Its lower time is 5. So this is also a bridge. Here comes 4 and 3. Here comes 4 and 3 or 4 and 1. So if we check at the time of DFS traversal, it being changed into 4, 1. I mistakenly not change it 4, 1. Okay, so when this compare with 3, 3, it can reach at 1 and its t in is 3. So this is also not a bridge. So it will update it into 3 into 1. When we check this and this, its t in 3 and its low is 1. So this is also not a bridge. So it will update into 2 into 1. So if this is a bridge, so this is also not a bridge because t is 3 and slow is 1. So if you remove this can also be reached at 1. So this is also not a bridge. So total number of bridges 3. So we can retain 3 for the bridges as well. Okay, so let's see the code of it. So here is the code. We have given the problem, we have given the n number of nodes, we can give the connections, means edges. Okay, so first our need is to create an adjacent matrix for the DFS traversal. Here we are creating, I think you know how to create adjacent matrix. Okay, now we create a vector t in, means the inning time, and the low is the lowest time. At lowest time we can reach it. Here is the bridges, means to store the answer bridge. Okay, and here is the DFS traversal, in which we passing adjacent matrix t in low bridges. 0 is the first starting node and -1 is its parent, and return the bridges. Okay, let's see the DFS code. Here we are creating a universal timer t equal to 1 starting from 1. Here first we make time node equal to timer, means we giving t in time as timer and also giving the low time as timer, and we increase the timer function, and we do the DFS traversal. We going to all its adjacent node, and first we check if x is equal to parent. So we do not go to parent. If it is going to parent, then we can continue it. Okay, now we check if t in is equal to -1. T in -1 equal, this means that this node is not previously visited. We are not creating any visited array, we don't need it. We can check that if this is -1, this means this node is not previously visited. So we call the DFS for it. Okay, we call the DFS for it. When the DFS for all the nodes completed, we doing backtrack and we check if these two are bridges. So first we take the node, low of node, means we taking the lower of the node as the minimum of low node and low of x. Okay, x is its adjacent node. So low of node is equal to min of low of node and low of x. We are taking the lower of both two, and if low of x is greater than time of node, means we are reaching at its lowest greater than the time of its node. This means we cannot reach if we remove that bridge at that point, at the lowest, means lowest of x means the reaching time at lowest to reach this node. But if this is greater than the t in time, means entering time of that node, so if we remove that bridge, we never going to reach that point. Okay, so we push that into our bridge. If that node is previously visited and this is not a parent, so we take the lower of node of min of low of node low x, means this again we take the lower of, means this is visited. This means we can reach these two, means if this is visited, there is no chance of bridges. Okay, this is no chance that there is a bridge because it can reach from the same path and it's already visited. And so take only the low of that means we both have the low. So this is the code, and if we can submit it in the LeetCode, it will give you almost 100% beat. Okay, thank you.